In lesson 3, we are going to look at creating a histogram. So in order to create a histogram, we're actually going to start with making a frequency table. So we'll see how that works with intervals. Let's look at the first example. It says the boys and girls basketball teams at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell hats with the school logo on the front. To obtain the correct hat size, the students had to measure the head circumference, which is the distance around the head, of the adults who wanted to order a hat. The following data represents the head circumferences in millimeters of the adults. The hats come in 6 sizes: extra small, small, medium, large, extra large, and extra, extra large. Each hat size covers a span of head circumferences. The hat manufacturer gave the students the table below that shows the interval of head circumferences for each hat size. The interval 510 to less than 530 represents head circumferences from 510 to 530, not including 530. Okay, so this would be any number up until 530, but does not include that 530. So this could mean 529 and 3/8. However, it's measured. Typically, millimeters are in decimals, but so it could be 529.99. So all the way up to, but not including 530. So it says complete the tally and frequency columns in the table to determine the number of each hat size hat the students need to order for the adults who wanted to order a hat. So it starts by giving us this frequency table. So we'll notice we have our hat sizes here. We have what head circumferences would fit for each hat size, a tally column, and a frequency column. So in order to fill in this frequency table, we're going to be looking at our list, and we are going to be seeing how many numbers on our list we have that fit in this interval. So if I look at the first number, it's 513. 513 would fall in the first one. It falls between 510 and less than 530. So I would make a tally mark to show that I have one of those. The next one is 525. That would also fall within this same interval because it's less than 530 but greater than 510. 531 is the next one on the list. 531 would not fall in this category because it's not less than 530. So that actually comes to the next one, and I would put a tally there. Now, if 530 was on this list, I would not put it in this first one because remember, it has to be less than 530. So 530 would fit in the next interval. So you have to be really careful there. Even though the 530 is listed here, this is saying less than 530. And the actual number 530 would go in the next interval. So what I would do here is I would go through the rest of the list. I'm going to do just what I was doing yesterday, crossing off as I tally for the entire table. So I am going to do that right now. Okay, so just to save some time, I went ahead and tallied each of those for us. So you would start by going through your list and tallying the information. And then and most of the times I'm going to tell you this list is in numerical order and it's already pretty much set up for us to do this pretty easily. However, most of the time when you collect information, it's going to be kind of all over the place. So that's why it's a good idea to go through number by number, cross them off, and tally them as you go. Now, frequency just means how many times it occurs. So we're just counting basically how many tallies we have. So for extra small or 510 to less than 530 millimeters, I have 2 people. For the size small hats, I have 8, then I have 15, I have 9, I have 4, and I have 2. Okay, so now they want to know what hat size does the data center around. We could look at doing our median here, and since the data is already in numerical order, we can do this somewhat easily on the list that's already given to us. So if we use our median, What we can do is we can either do that one for one, beginning to the end, or we can see how many total pieces of data we have and divide it by 2. So if I add them all together, I am going to see, I'm just going to add kind of over here to the side, I have 2 plus 8 is 10, 9 plus 4 is 13, plus 2 more is 15, and I have the 15 here, so I end up with 40 pieces of data. So if I take that 40 and divide by 2, I get 20. So what that means is I'm going to count to my 20th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Since we have an even number in the set, we had 40, which is an even number in the set, we're going to count to our 20th number, which means we have 19 numbers before it, and we have 20 after it. So it's not split equally. So I'm going to take this number and the number that falls after it and look at these two numbers. Now in this case, these numbers are the same. 563, 563. If they were not the same, and I'm just going to show you the steps even though they are the same number, I would do 563 plus 563, and then I would take what I get from adding those two center numbers and divide it by 2. So this is actually called finding the mean of these two numbers, and we'll see that coming up in a future lesson. 2 goes into 11 5 times. 2 goes into 12 6 times. And 2 goes into 6 3 times, which we get the same number because, of course, they're both the same number. If they were different, we would get a number that falls directly in between those two numbers, and that would be your median. So our median is 563, so we would need to find which interval that 563 would fall in. It's greater than 550, but it's less than 570, so the median would fall in the medium hat size. Okay, so the next piece is that we are going to look at how we can take our frequency table into a histogram. One student looked at the tally column and said it looked somewhat like a bar graph turned on its side. A histogram is a graph that is like a bar graph, except that the horizontal axis is a number line that is marked off in equal intervals. To make a histogram, draw a horizontal line and mark the intervals. Draw a vertical line and label it frequency. Mark the frequency axis with a scale that starts at 0 and goes up to something that is greater than the largest frequency in the table. For each interval, draw a bar over that interval that has a height equal to the frequency for that interval. So we're going to look at this. If we're looking at this histogram that they've started for us, you'll notice along the horizontal axis, they have put the numbers that exist in our intervals. So the first one went from 510 to less than 530, so that's the next number that they put down. The next interval went from 530 to less than 550, 550 to less than 570, and so on. So that's our interval axis, and something that's important there is this little mark here. That allows you to go from 0 to whatever you want to count by, to the first number you want to start counting by, I should say. So we're going to jump from 0 to 510 and then be able to start counting by 20s. Typically you have to have everything equal, but this will allow us to skip jump all the way to start at 510 since our data is all 510 and above. Then along our frequency column, we start at 0, and I should also mention that goes the same along both axes. You have to start at 0, always, always, always. So we start at 0, and then we want to count all the way up until we're at least one above the highest frequency. And our highest frequency on our frequency table was 15, so this one goes to 16. Based on that, you're going to kind of decide if you want to count by 1s, 2s, 3s, 4s, 5s, whatever. in order to fit on that graph. But you want to make it so that you can fit on whatever graph you're given. So the best way to do that in this case was to count by 2s. So that's how they did that. Notice this is labeled frequency and this is labeled head circumference. So then they just took the data from the previous frequency table. The first one, the 510 to less than 530, had 2 people that had it, or their frequency was 2 people. So they drew a bar that started from the 510, went over to the 530, and went up to 2, and then shaded it in. So just like a bar graph. Another big difference between a bar graph and a histogram is that in a histogram, because we're dealing with intervals, the bars are going to touch each other. So notice this first bar touches that second bar. So between 530 and less than 550, there was a frequency of 8. So we're just going to continue on. The next one would be 15. So directly between 14 and 15, I'm going to draw a line across, bring my bar down, bring my bar down. Okay, and then typically you would shade in. I'm just going to shade quickly with a yellow here. Okay, my next frequency was 9. So draw my bar here. Then I had 4 for the next one. And the last one was 2. Something to notice is that because we're counting in intervals across, all of our bars are the same width. And that's something that's also very important in a histogram, is that your bars are in fact the same width. Okay, so I think I covered everything I wanted to say about an actual histogram. The bars touch. You can use this jump. Your interval should be labeled like this. Label here, label here. This is always your frequency in a histogram. So this says, based on the histogram, describe the center of head circumferences. So in order to find the center in a histogram, what you do is you start by adding all of your frequencies together to find the total number of pieces of data. So we're going to pretend we don't know from that histogram what we got. So I'm going to label above it. I find that a little easier. So this was 2. I'm going to put a 2 here, 8, 15, this was 9, 4, and 2. And I'm going to add those numbers together. So 2 plus 8 plus 15 plus 9 plus 4 plus 2. Now we already added this previously to figure out the number of pieces of data we had, and we got 40. After you find the total for your frequencies, you're going to divide it by 2. And we get 20. So what this is saying is that if we start in from the beginning and move over 20 pieces of data, that's where we'll find our median. So what that's saying is if I start from here and I count in 20 pieces of data, so this is 2 pieces of data, this is 8 pieces of data. Okay, so from here to here is 10 pieces of data. Okay, so we're still not to the 20 we want to get to. So if I go 10 plus 15 more, that's going to give me 25, which would bring me over the 20 pieces of data. So what this is saying is somewhere within this bar, or this interval, would fall our center. Okay, so you add the frequencies all together, divide by 2, and whatever you get, you're going to count over from the start. So 2 plus 8 is 10, 10 plus 15 is higher than this number, meaning our center would fall somewhere within this bar. So our center is said to be within the 500 to, less than 570 bar. Okay, so how would the histogram change if you added head circumferences of 551 and 569? And both of these fall in the same interval. They both fall within the 500 to 500, less than 570 bar. So that means that that bar would go up 2 to 17. Okay, so the 500 to less than 570 would go up 2, bringing it to 17. Bringing it to 17. Okay, so this is just going from 15, add 2 more pieces of data to bring it up to 17. Because the 40 head circumference values were given, you could have constructed a dot plot to display the head circumference data. What information is lost when a histogram is used to represent a data distribution instead of a dot plot? So the difference here is with a dot plot, if we were putting all of these pieces of data on there, we would be able to see the exact number of each of those head circumferences. So in a dot plot, we see all of the values. Okay? Here, I am not getting specific numbers. I know there's 2 that fall within this range, but I don't know exactly what 2 numbers they are. So a histogram, we only see a total number for an interval. So histogram is just a total number for an interval. So while dot plots are much more specific, there are times when a histogram is more effective. So if you want to know the exact numbers, you would want to use a dot plot. This says, suppose that there had been 200 head circumference measurements in the data set. Explain why you might prefer to summarize this data using a histogram rather than a dot plot. And I'm hoping that you guys could all see at this point, who wants to make 200 dots? So when you have large numbers of data, you want to use a histogram. It's too many dots that you would have to make. It would be way too hard to read with putting 200 dots above different numbers. A histogram really works for large data sets because you can adjust the frequency scale. So you can make it so that you have smaller intervals, so it can just be a couple of numbers in each interval, so you'd get a better idea of how many fall within each. But you're not making dots for 200 pieces of data. Okay, so it's too many dots. And with a histogram, you can adjust the frequency, and it works better for that large data. Okay, so the next thing we're going to talk about is shapes of histograms. A histogram is useful to describe the shape of the data distribution. It is important to think about the shape of a data distribution because depending on the shape, there are different ways to describe important features of the distribution, such as center and variability. A group of students wanted to find out how long a certain brand of AA batteries lasted. The histogram below shows the data distribution for how long in hours that some AA batteries lasted. Looking at the shape of the histogram, notice how the data mounds up around the center of approximately 105. We would describe this shape as mound-shaped or symmetric. If we were to draw a line down the center, notice how each side of the histogram is approximately the same or mirror images of each other. This means the graph is approximately symmetrical. So what they've done is they found where their center of their data would fall, which they're saying is at approximately 105, so right here, and they split it up there. So that's where they're splitting it. That's the median. So if you look on either side of this line, and what I usually do to figure out the shape is I'll kind of skim the corners of all of the bars like this to get a general shape of what it looks like. So here you can see it is mound-shaped, and it is approximately symmetrical on either side. So this bar is about the same height as this one. This one and this one look to be about the same height, and this one look to be about the same height. So on either side of this line, it's pretty much symmetrical. So this would be an approximately symmetrical shape. Now, if we were to do this and draw a line, there's 2 different ways we say it's skewed. So if it's skewed left, so if we drew our center and we drew our little mound around it, we would see that it kind of tapers off to the left. So we call it skewed towards the smaller values, which would be to the left. If it's skewed right, again, if you draw your little mound around your data and it's skewed towards the larger values, so those numbers kind of hit down here, that's called skewed right. Okay, and then this one is just another mound-shaped or symmetrical shape. So again, you trace kind of along the outsides and see how it's shaped. If it's shaped or skewed left, the smaller values are to the left. If it's skewed right, the smaller value or the larger values are coming down here. Okay, so another group of students wanted to investigate the maximum drop length for roller coasters. The histogram below shows the maximum drop in feet of a selected group of roller coasters. This histogram has a skewed shape. Most of the data intervals are from 50 to 170, but there are two values that are unusual or not typical when compared to the rest of the data. These values are much higher than most of the data. So if we were to draw our little mound, we start here, and we can kind of go like that. So you'll see it's shaped like this. If you look up here, it's similar to what we're seeing here. So this would be skewed right. Okay, so it would be a good idea to kind of get to know these shapes so you can determine which shape your histogram has.